Welcome, everyone. I think we're in session now. From local to global, sky to ground cooperation enabled by OGC Innovation Initiatives for Disaster Risk Reduction. And I'll turn things over to Mark Reichert for introduction. And we'll turn the slides on.
Thanks, Josh. Good day to everyone. Welcome and sorry for the few-minute delay in getting started. Well, I think all of you know about the OGC, but I'll just briefly talk about the innovation program and set the stage for the work that we're doing in disaster readiness and reduction. So OGC, as you know, is a collection of the global experts for all things location. We work to advance open standards and best practices to make it easier to bring together geospatial information for improved decision making. And we very much promote, next slide, Josh. We very much promote FAIR principles, findable, accessible, interoperable, and reusable. Next slide. And we have over 550 members representing government, business, academia, research, and not-for-profits collaboratively engaged in advancing the mission of the OGC. Next slide. The innovation program is an interesting and important part of the Open Geospatial Consortium. In addition to our consensus standards process, we have the Innovation Lab, which essentially allows us to tackle very difficult developmental challenges for new levels of standardization and interoperability, but also to bring together communities, users, and technology providers hand in hand to do rapid prototyping and engineering to address real-world challenges. And this really allows us to not only advance standards that work, but standards that are relevant to various communities. And it allows us to do it very, very quickly and develop the type of evidence needed to make that standard work globally. Next slide. And each of these initiatives that we have deals with different levels of maturity. So the whole goal is if we get together for development, we push that through to workable standards, and we work with communities of interest to basically align them to a common infrastructure of interoperability through things like pilots and plug fests. Next slide, Josh. The results of the innovation program are proofs of concept, open standards, and community practices. All of those things help us push the implementation globally from local to global. Next slide. So the disaster pilot is it's a culmination of a lot of activities in OGC within the innovation program. Its goal is to develop standards-based services to make it easier to rapidly support decision-making in the disaster lifecycle. So usually today, most of the effort is trying to deal with a deluge of different types of data. What we're doing is creating standards-based processes to integrate, process, and transform data in an automated fashion into analysis-ready data for further analysis for decision makers, and to create decision-ready information that can be used at a moment's notice to deal with disaster activities. We're focusing on, of course, open standards framework, optimizing and using cloud services to the maximum, and dealing with the reality of connected and disconnected operations. And we're also dealing with how to improve the capability for web search specific to different types of disasters. We're dealing with scenarios based on flooding, landslides, and pandemics, and that'll be talked in a little more detail by Josh. Next. We have a whole range of players in this process. We thank our sponsors, the USGS, FGDC, Natural Resources Canada, NASA, CNIDA in Peru, and AWS. They're sponsors and supporters of this initiative, providing us with resources. And on the left side are a list of all of our participants, OGC members that are participating and providing capability. And then finally, stakeholders from around the world who are helping to give us insight as to the problems on the ground and to help validate the work that we do going forward in this pilot. Next slide. And the disaster pilot is just one of many initiatives that are underway. We're focusing in a number of relevant areas that are current and very, very challenging for us as a global society. And I invite you all to take a look at those activities on our website. The link is provided here. But it's all about innovation to operationalization, fast-paced activities to get results quickly, focusing on collaboration and global partnerships, and creating community impact. Josh, back over to you.
Thanks. So as Mark has shown you, this is an activity very much in line of OGC's mission to promote data sharing and geospatial awareness, and in this case, specific to the scale and seriousness of the problem of disaster management and response. And one indication of that is the number of participants. I think this may be one of the largest groups of participants in a single interoperability architecture that we've ever undertaken. Many complicated aspects of this, but a lot of potential for value. As the bio shows, I've sort of been working towards this my whole life in earth and environmental sciences, IT architecture, and geospatial science. And one important aspect of this pilot activity has been the need to focus on specific hazards, regions, and time intervals. We're trying to develop capabilities and capacities that are applicable globally and to a wide variety of hazards, and really increase the capability for near real-time response. But in order to develop those, we've had to focus. So we're focusing in Peru on landslide and flooding hazards, together with pandemic impacts. How do you keep people safe who are health impacted as well as natural hazard impacted? And we're focusing on the Rimac and Piura river basins in the interval of occurrence of flooding and landslides in February and March of 2021. The second sort of piece of focus is flooding hazards and pandemics in the Red River Basin in Manitoba, Canada in March, April 2020. And then the third scenario is really focusing on the pandemic response and matching up between available data and the data that we feel is needed for a proper awareness and intervention of the health situation. So we focus here on the fact that there's lots of data available, there's lots of things to do, but there are significant points where this information is not getting through and collaboration sharing is not happening. There are 5 major pieces of this. It's turning output from sensors and models into analysis-ready data that can be processed and exploited at scale and at the necessary speed using cloud computing infrastructure. Then using data and API standards to bring that into the development of decision-ready indicators. So information which is ready for action through the development of collaboratively developed recipes for using the ARD to produce these indicators, and then sharing those in challenging environments through geo-packages and various forms of online, offline collaboration. Also reaching out to the public through the use of linked data and web search optimization, geo-search optimization, as well as the reporting into this interoperability framework for public and population health. There we go. So this leads to a value chain where data from satellites and elsewhere is worked on through a collaboration from providers and practitioners and analysts, from analysis-ready data to integration-ready data to actionable observations, and then through application of rules for action to decision-ready indicators that help practitioners to be aware, to be prepared, or to be beware. Yep. So these are the parts that are going into our pilot and are being worked and developed in terms of capacity and tools and techniques from all of the participants and sponsors. So now we'll turn to the sponsors and participants for some vignettes of the work that they're doing. Ryan, over to you.
Great. Thanks, Josh. You can go ahead and skip to the next slide. So thanks everyone for attending. It's great to be here today. So my name is Ryan Ahola. I'm an environmental scientist with Natural Resources Canada. I'm the technical liaison between our department and the OGC, and I'm leading our department's participation in the disaster pilot. If you'd like to go to the next slide, Josh. So just a quick overview of Natural Resources Canada. So if you well, from our name, we focus on everything related to natural resources in Canada. So this comes down to energy, mining, minerals, really anything related to natural resources. We do have a role in multiple different types of disasters that affect Canada and also internationally. One of the more common things that we do is around satellite-based monitoring of flood events. There's an example of this shown on the right side of the slide for actually some very significant flooding that is occurring in British Columbia right now. So the area near Abbotsford has been completely flooded. You can see some images at the bottom of the slide on the severity of the flooding, and the image above shows one of our satellite-derived flood products. So certainly in the context of the pilot, what we've been interested in is seeing how we can achieve near real-time disaster information flows through standards, particularly in the context of Earth observation. Because in the context of major flooding events, such as what we've just been experiencing, minutes count. So being able to shorten the time between satellite image acquisition and going to a product that could be used by disaster responders is critical. So the outcomes that we're seeing within the pilot, particularly around satellite analysis-ready data, are very encouraging. So we definitely see a path towards achieving the vision that we want to get to help manage some of these disasters. So we're certainly looking forward to continuing this work in the future, in particular with the sponsors that we've been collaborating with. So I think that's it. So thanks everyone, and I guess we'll move to the participant presentations.
Next up, we have Gustavo Henriquez from CONIDA.
Yes, thank you, Josh. So distinguished members of GEO community, dear participants of this side event, it's a pleasure for me to address you virtually. My name is Gustavo Enriquez. I work in the Peruvian Space Agency since 1997, different posts, and currently I am the head of cooperation and international affairs. And I am pleased to share some comments related to our participation in the OGC pilot project. So Josh, maybe can you share excellent. Yes. So I will just use this only slide to show you what has been the big numbers of PeruSat-1 project. The first remote sensing satellite system we implement in Peru. And I would like to focus on the pie in the center of the slide. So you may see how has been the distribution of this data since 2016 until today in the different sectors. We may see that disasters are the most demanding sector, as following by security and defense. But we have realized that there are some sectors that we would like to improve in their capabilities, like, as for example, regional and local governments that are currently not using extensively the satellite data. So our main motivations to go inside this pilot project were to fill these gaps that we realize in these potential users. For example, the lack of software, the lack of hardware, and also the lack of training experts in image processing. All these barriers, technological barriers, prevents these users to access and produce information and improve decisions. So OGC pilot projects in Peru is related, as Josh mentioned before, to floods and landslides. And we choose this specific application because, as you see in the picture, these are more demanding and is very important for the stakeholders, these activities. Um, Floods and landslides are the most severe concerns during the summer, especially during ENSO phenomena here in Peru. And CONINA has worked closely with participants to upload on the cloud Perusat-1 the satellite data, as well as to build capabilities and establish standards. So other local institutions, the data of other local institutions may be interoperable. In this sense, one of the main advantages that we see in this pilot project is that in a short time, a real situation application may be set up, and during all this process, a strong collaboration among local and foreign participants is developed. For us, the model works very well since different participants working together around the one main goal may accomplish their own objectives, like, for example, better understanding of cloud technologies or perhaps online processing technology of big data. I like to emphasize that even when cloud computing is not new in informatic community, for Earth observation community, these new technologies are beginning to be ingested and explode. So this is a good moment for us to be in this trend. We consider these OGC pilot projects are a suitable model for easy the access to data, not only in Latin America but also in other regions. And for Peruvian Space Agency, we may annotate as a benefits the implementation of the platform for granting data access to users, also development of working relations with other institutions, local and internationally, and getting knowledge about cloud technologies as well as develop local useful for decision makers. I would like also to comment that, as Mark mentioned at the beginning of the session, this work is aligned to the idea that data should be findable, accessible, interoperable, and reusable. And we may think about how to connect local initiative needs with the experience and technology behind these pilot projects. So we may speed up the adoption of capabilities by the Earth observation community. So thank you very much for your attention.
Thank you, Gustavo. And next we turn to Professor Peng Yue from Wuhan University.
Hello, hello everyone. It's my pleasure to present the work from Wuhan University. Next slide, please.
Oh.
Yeah, this
Yeah.
slide shows. Oh, I think it goes faster. Yeah.
Okay.
You come back. Okay, thank you. Right now, I'm the Deputy Dean at the School of Remote Sensing and Information Engineering from Wuhan University. we organized the OGC channel Frozen, and also I worked in IEEE ESI committee before. Next slide, please. Yeah, Wuhan University recently worked in DP 2020 first. And we also joined the test bed 17. We are organizing the standard working group for the training data markup language for artificial intelligence. And we also have several other OGC-related activities. We did join the disaster resilience pilot 2019 in 2019. The next slide, please. Yeah, in the disaster pilot, this is the role we provide the data access to the open EO provider like the Sentinel data and the Modis data. We also can access data from the stakeholders in the DP21 and related open geographic data. And this data, open EO data and high resolution EO data, are processed into the analysis ready data for the scenario in this in the DP. So this ARD data can also be ingested into the GeoCube, a multi-source data cube system developed by Wuhan University. Next slide, please. This is the GeoCube. It actually uses a multi-dimensional data model, which can not only ingest the raster data, but also can accommodate the vector and the tabular data. So it has been developed in the past several years and has been also used in the test bed. Next slide, please. Next slide. Okay. So in the scenario, the flood event in the Red River Basin, this is a static area, and for the flood event, we prepared the ARD data. Next slide. First, we developed a tool. These tools can be used in the DP21 to access the spatial temporal data sets from open data providers. It provides it can access the USGS data and ESA data and NASA data. It provides a unified and user-free and friendly interface, like the Python API and command line tools. So this just shows some snapshot to access the Sentinel data. Next slide, please. And when use these tools, then we download, we can query and download the data. Then we process this data into analysis ready form for the DP21 flood. This data analysis ready data then can also be ingested into GeoCube by processing them into the high performance ready form. So GeoCube can also combine the ARD and cloud computing to provide a platform for serving the ARD data. So that's all. Thank you for attention.
Thank you very much, Professor. And now we turn to Omar Barrilero. Apologies for all pronunciation.
No, it's okay. Thank you, Josh. In fact, I noticed that my name is wrong here in the in AirMeet. So I'm Omar Barrilero. I'm an aerospace engineer. I'm working in SATSEN as a project officer, and mainly providing technical expertise in the Earth observation and IT-related activities. Next slide, please, Josh. Firstly, I wanted to introduce SATSEN. SATSEN is the European Union agency supporting the European Union in the field of the Common Foreign and Security Policy. And in particular, I'm working in the RTDI unit, which is implementing new operational solutions looking at the whole Earth observation and collateral data lifecycle. We are working mainly in the topics like new data sources, secure SATCOMs, innovative technologies, or developing new applications. And for this, next slide, please, Josh. For this, research and innovation and cooperation are essential for our task. With this, we are able to enhance operational processes and capabilities, to explore new applications areas and technologies, to cooperate with industry, academia, and final users to start technological developments, and also to work in the standardization of and interoperability of our solutions. It's for this that we are also participating in different OGC pilot. For example, last year we participated in the Earth Observation Applications pilot, and this year we are participating in the Disaster Pilot 2021, where we are developing applications to detect changes using Sentinel-1 in order to generate change maps and other products to support decision makers in flooding scenario. Please, next slide. In particular, we are focusing in the floodings in Peru because it's affected by multiple events and with different causes. I wanted to highlight this because when we think about indicators and flooding, we are mainly thinking, for example, on monitoring of the flooding or the consequences, but it is also important to know that there are indicators to try to forecast these events. And in particular, for example, El Niño has two different variants, the global and the local, that is also known as El Niño Costero. And depending on this variant, different indicators regarding the sea temperature, for example, in different areas of the Pacific Ocean have to be followed. As example, you can see some some indicators also about the precipitations in some Peru regions that happened during the El Niño Costero event in 2017 in some regions in the coast of Peru, where we see a very increase of the precipitations in Lambayeque or Piura, for example. Next slide. For this, the study we have made during the pilot, we are focusing in Sentinel-1 and Sentinel-2 data. We consider this as an analysis-ready data. We have processed this Sentinel-1 and Sentinel-2 data. And in fact, we see that Sentinel-2 data, that are the images above, it is very useful. But the problem is that Sentinel data with the optical images are affected by the cloud. So it is not, they are good when there are no clouds, but during the events of the floodings, it's usually very covered by clouds, so it is not very useful. And the Sentinel-1 data, when calibrated, can be used also be compared between them in order to get some information about the floodings. Next slide, Josh. With this analysis of the data, we are generating decision-ready information or indicators, like for example the ACD or NTC, that are the images in the top of the slide. The ACD in the upper left is a composite of the change in the backscattering and the amplitude, and they are highlighted in red the areas that are flooded. And also the MTC is a composite generated with the backscatter for the analysis of the data. but also with the coherence. The coherence is a measure of the similitude of the amplitudes of the images, and it is very useful to detect changes. But we have seen that, for example, in the flooded area in these regions, it is not very useful because the vegetated area and the flooded area have similar coherence, so we cannot see very well the difference. And with this kind of decision-ready indicators that are mainly made for visual analysis, it is also possible to automate the generation of flooding index or the generation of max by using different thresholds. And they can be used later by other processing tools or visualization tools to generate more advanced exposures, like, for example, compute the intersection of this flooded mass with the roads, bridges, in order to identify affected infrastructures and routes, to generate some time series analysis and evolutions, and to generate final reports for the decision makers. Next slide, Josh. This was my final slide. Thank you.
Thank you very much. And now we turn to Fabrice Brito from Terra Due.
So hello, everybody. Thank you for coming. So I'm here today to talk about the geodata value stream. between the acquisitions from the satellites to supporting the decision-ready information. So I work at TerraDo. TerraDo is a small company based in Italy that has a strong background in cloud computing plus Earth observation data. So our role is to combine the resources from the cloud plus the assets coming from different space agencies and put that together to better serve partners and clients in extracting value out of Earth observation data. So Josh, next slide, please. So in our participation in the Disaster Pilot 21 brought by the OGC, the question that we had is what happens between an Earth observation product acquisition coming from a satellite mission to the decision-ready information. So we wanted to understand what is the value stream for each of the functions listed on the left to support the generation of decision-ready information. So next slide, please. So first we have identified the steps that we need to do so. So we have first the ingestion of an EO acquisition, and then we calibrate that. So we convert the digital numbers to geophysical value and enabling then the consumption by other parties for the delineation or risk assessment, etc. And leaving another set of let's say, protocols and standards for exploiting and disseminating this decision-ready information. Next slide, please, Josh. So our approach here is basically to take the EO acquisition, and the first step is the ingestion. And when we do the ingestion, we create another object and we enrich the metadata. And when we say we enrich the metadata, we add for each of the missions all the information that we need to do the calibration. It can be optical calibration. In such a case, we need the elements to convert the digital numbers to radius and then reflectance, may it be on top of atmosphere, bottom atmosphere. And for the SAR calibration, we need the process to do the SAR calibration, the terrain correction, to get the backscatter implemented as sigma north in dBs. So you see for the discovery content, data access, data format, and visualization, we have identified what we need to do the elements in the ingestion. And we move the data through the cloud, so we have object storage. The data format, when it's ingested, is not manipulated, it's still native. And the visualization is often just a simple quick look. But then we apply the calibration, and that happens with the OGC API processes and other standards for the implementation of this. And the output of that is the analysis-ready data or the process-ready data, a term that the testbed 16 has identified, which is data that is ready to be processed on the cloud to derive decision-ready information. And what do we get there? Well, we get a stack item with its assets with common dictionary for identifying the band. So the red band will be a red band for all the mission having that payload. The content is then reflectance scaled in a defined range for optical data. Then we have sigma naught in decibels. The storage is supported by the object storage. The data format in terms is the cloud optimized GeoTIFF. So the data stays in the cloud storage and stays in the optimized format for consumption. And then we have advanced visualization protocols offered by the OGC, such as the Web Map Tile Service, Web Map Service, Web Coverage Service. And at that level, we can support the decision-ready information actors in the field that then consume these RDs to generate the information for the operations on the ground or other coordination efforts. So this is our answer to the question on the value stream between the Earth observation product acquisition up to the decision-ready information. Josh, that was my last slide. Thank you.
Thank you very much, Fabrice. And now we'll turn to Mark To Ajay Gupta, sorry. There we go. Ajay, you need to unmute.
Okay, thank you. Thank you, Josh. My name is Ajay Gupta, CEO of HSR.Health. We are a geospatial health risk analytics firm that provides insights on the relationship between social determinants of health and health outcomes and costs. We've leveraged these insights to produce health analytics for the COVID-19 pandemic globally, including throughout the United States and Africa. I have the privilege today to speak on leveraging EO data for health applications that we're doing in the OGC 2021 disasters pilot, and those that we would like to build in the future. As satellite imagery becomes more and more sophisticated, it can have a role to play in early disease notification. Next slide, please. During the pilot, we have used Earth observation data to identify areas impacted by a flood and landslide in Peru. By identifying the impacted areas, we gain visibility into the underlying health posture of the affected populations. Specifically, we have developed a medical supply needs index that determines the level of medical supplies, such as gloves and other personal protective equipment, needed per facility to treat the anticipated patient load. We have created this for the US and for the Rimac River Basin in Peru. Next slide. With the medical needs supply index, we can identify the pre-disaster medical supply needs and routes, shown here for specific medical clinics within the Rimac River Basin, and the purple lines demonstrate supply routes from warehouse locations. Next slide. The index can ingest real-time data on floods and landslides to update the identification of at-risk populations, available medical facilities, and their supply needs, and therefore route changes due to the coincident natural disaster. As seen here, 2 specific locations, medical locations, are flooded, and therefore the patient population goes to another locations, and that changes the supply routes. Next slide, please. Additionally, over the course of the pilot, we have provided input on expanding the data model from the Health Spatial Data Infrastructure Concept Development Study, as well as identified additional health and pandemic use cases for Earth observation data. A few examples include satellite imagery can potentially be used to identify pollution of rivers and streams, which can affect water quality, where potential contamination of drinking water may have occurred, air quality analysis and its potential health impacts, and the health impacts of climate change more broadly. A pandemic-related application of Earth observation data is to identify the intersection between urban areas and wildlife habitats, as these are areas that can be flashpoints for zoonotic spillover events. The nation of Peru is an ideal country for health risk analytics and zoonotic modeling, and for many reasons, including the effects of climate change on its tropical climate, urbanization, deforestation, and the wide range of natural disasters the country experiences, including floods, wildfires, landslides, and earthquakes. These can affect the habitat of wild animals, leading to greater interaction with human populations, increasing the risk of zoonotic spillover. In addition, there is good infrastructure and access to health and social data in Peru down to the Admin 3 or district level, which is key for health analytics. Finally, PeruSat-1 presents a great opportunity to use new satellite systems and technologies for health use cases. Next slide. There are many more ideas. Next slide. At the upcoming Health Domain Working Group session on December 7th, during the OGC's member meeting, we have a discussion on all of these Earth observation use cases for health. Next slide. The members of the OGC's Earth Observation Domain Working Group, as well as all interested parties here, are invited. Next slide. Thank you for taking the time to listen to this discussion on health and EO work related to the OGC 2021 disasters pilot and the future applications of Earth observation data to health that we want to pursue. Thank you, Josh.
Thank you, Ajay. Let's turn next to Mark Corver of Amazon Web Services.
Hi, everybody. This is Mark Corver. I'm based in Seattle. I am the worldwide tech lead for geospatial at Amazon Web Services. Next slide, please. We can just keep going. Next one. Yeah. So we are, let me see. Amazon Web Services is the world's most comprehensive and broadly adopted cloud platform. We have over 200 fully featured services, data centers globally, millions of customers, fast-growing startups, enterprises, leading government agencies. But our main goal here is to help you lower costs, become more agile, and innovate faster. Josh, I think we jumped ahead a little bit too far. Could you go back? Yeah, to the map one.
Oh, we are on the map one there.
Oh, okay, that's fine. So as part of this, we provide support for OGC innovation pilots, including the disaster pilot and annual OGC testbed work. And part of the reason we're able to do this at whatever scale participants want is that we have 25 geographic regions around the planet, and we have 9 more in the pipeline in places like Australia, Canada, New Zealand, Spain, Switzerland, and the UAE. So if the cloud isn't already close to where you are, it is getting closer every day. Next slide, please. And I think the main reason the cloud should be interesting for anybody doing any kind of Earth observation work is that it's easier to share data in the cloud. And it's even better if you're sharing analysis-ready data, which has come up multiple times, which allows people who are interested in your data to work with the data in situ without having to move it. Next slide, please. And so what I want to point out here, and this is probably something I can't overemphasize, is that the traditional approach, as you can see on the left, is about going to, traditionally for satellite scenes, it would be, probably FTP servers. Then you go to those FTP servers, download data to some local workstation, and then operate on that data. But that model has been, flipped, I think, now for some time. And the cloud approach is the opposite. The data is oftentimes already in the cloud because they are public sources. For example, ESA Sentinel data or USGS Landsat data and many other kinds of data are already in the cloud. So it's more about bringing your compute, your ideas, which might be as simple as a Python script to the data, not the other way around. Next slide, please. And so what are the advantages of moving to the cloud? The font seems a little bit funny here, but I'll go ahead and read it. So you have access to a global community of users who are using the same kind of infrastructure that you are, meaning they can share tools and methods, not just the data with you. So you have easier access to reproducible science because you're collaborating in the cloud. And when you're working with data in the cloud, or whether it's yours or somebody else's, that data is sitting right next to over 200 different services that you have access to that allows you to focus on whatever your particular problem set is, rather than having to reinvent the wheel. And what that means is that you end up with a faster pace of research, and because you're faster, you have a lower cost of research. Next slide, please. And if you want to learn more about this, as I mentioned earlier, there is already a lot of data in the cloud, and I think that AWS has been a front runner on this via our Earth on AWS program. You see other cloud vendors basically doing the same thing, and you can discover what kind of data is out there by going to Open Data on AWS. We call it the Registry of Open Data, or RODA for short, and then just look for data and discover. Do some discovery there. And just remember what I said earlier, it's not about downloading the data, it's about moving your code to the data. Thank you very much. That's it for me today.
Thank you, Mark. So next, very quickly, we'd like to show remarks from General Garcia, the head of the Peruvian Space Agency.
Of the GEO community, esteemed participants of the site event from local to global, sky to ground cooperation enabled by OGC Innovation Initiative for Disaster Risk Reduction. It's a pleasure for me to be able to address you today virtually to share a few words from Lima. When Peru set Peru SAT-1 satellite system into operation back in 2016, we began to have a large amount of data on our territory, not only from our own satellite, but also from other satellites as a result of exchange of image agreements, and all this information has been delivered to institutions free of charge. We also realized that local users produce value added in a traditional way, so we identified a need pointing to provide capabilities based on new processing technologies on the cloud, and also allowing institutions to share their data effectively, and that means using standards. This led us to work within AMERIGEO, where Peru has been a co-chair since 2019, and as a result, we are now in the framework of the OGC pilot project that will be discussed in this side event. For Peru, participation in one of these pilot projects has been a great learning experience. Now, despite the fact that the project has not yet concluded, great value has been generated ready to be used, as well as is available the experience and the technologies. In addition, we have benefits within the local community in terms of standards and interoperability in a subject of enormous importance for our country, floods and landslides. I would like to emphasize that from our position, we support the principles that are being promoted with the OGC pilot project model that allows working on the basis of an identified need and arriving to a real solution that we may scale up, and besides, in the process, links are established among public and private, local and international organizations. Data and experience is exchanged among participants, and we gain connections of work and trust for joint capacity generation, and the best is that all this may be reusable in similar projects. This kind of ecosystems is what GEO promotes in the countries. Joint work pointed to Earth observation data are available when it's necessary, generating value for decision making. Peru has initiated this development, and we would like to invite you all to learn more about this topic and share your knowledge with others to accelerate similar initiatives in other regions. Finally, I declare initiated the side event from local to global sky-to-ground cooperation enabled by OGC Innovation Initiative for Disaster Risk Reductions. Thank you.
Thank you, General. And thank you to everyone who has joined and participated in this session. I'd like to invite you all to join us tomorrow for the second session of From Local to Global at 10 a.m. Central European Time. And we'll continue to explore this notion that the fair application of EO data to disaster awareness requires many things. It requires technologies and tools, planning and collaboration, capacity building and needs assessment, but it really needs standards too. It needs those durable, agreements to share data that we can bring out and put into operation when they're needed and not when we get around to it. And the other part of our learning here is that cloud computing is a revolution in the preparation and access for data that's ready for use, but it's the collaboratively developed decision-ready indicator recipes that lead to truly informed action. So thank you for coming, and we'll look forward to picking this up again tomorrow. I think that's it.
Okay, bye-bye.